Okay, so this is video number 82. It's 5:15, and as promised, I'm going through the test little by little. There you see the test number here, and I'm doing problems 29 and 30. I'm going to spend a little time with 29. I think it's worthwhile. And so the question is, what's the area of this octagon? And I'm going to, just as an exercise, I'm going to calculate as well. I'll involve a calculator here. I'm going to calculate the perimeter as well. So let's see what we have here. The object is obviously regular. What they mean to say is this is 11.6, this is 11.6. So when we do a problem like this, we're thinking two trapezoids, the top and the bottom. So if we calculate 1 and we multiply by 2, we should be in great shape. The height, perpendicular, a word you should be very familiar now, is 8.2, and the one base is 11.6, and then if you subtract 11.6, let's make sure that since we did the word from 28, okay, so hold on, so you're going to 11.6, and then the base here is 28, excuse me, okay? That will be the next step I do. And then we're going to add the rectangle in the middle. And you can easily calculate that since the bottom is 8.2 and the top is 18.2. When you subtract 16.4 from that, you get 11.6, which shows you that this is a regular octagon. We'll talk more about that later. We're going to actually use radicals to prove that it really is a regular octagon. But we'll get to that in a second. Okay, and now I subtracted 28 from 16.4 to get this, which is 11.6. So we'll show later that this is around 11.6. They're achieving a little. And then the length over here, of course, is 28, as you can see. Okay? So there we go. All we have to do is multiply this number by 2. The height is 8.2. And we're multiplying that by 11.6 plus 28 divided by 2. And then we're adding 28 times 11.6, so that's the area here, twice the area there. There's the cancel, and so you should be easily able to do this. And when you add everything up, you multiply this times the sum of this plus the product of this. You can check me on the calculator. You're going to end up with 649.52. When you read the question, I'll round it to the nearest tenth of a centimeter. So this is there, and rounded to a tenth really should be 49.5, but they write choice C. I'm questioning their wording there, but it's okay. The clear answer is C, and as a matter of fact, I didn't write that down. You should write all the answers down. And 29 is C, and 30 is going to be D. And I'm going to do 31. I'll put that over in the corner here. And that's an easy one. That will turn out to be C. All the answers need to be put out properly. So there we are. Okay? And it looks like I went a little over to the side too much here. I'm looking over here. So I'm showing you what's going on. There's the check. There's the addition. And there's the answer that you should get. Like I said, we're breaking things up into pieces and adding them together. Aha, the old idea of a compound figure. Okay, so now I'm going to slow the whole thing up again since the math is pretty clear here. And I want to show you that the math that we did as enrichment works just as well here. I'm going to show that that this is a regular octagon. That is, all the sides or about 11.6, and I'm going to come close to 11.6 because, again, as you should be aware of, especially as you go into science classes, let me move this over just a tiny bit, then you'll see that when you just round a little bit, you change everything. So the point here is to find what this is, and if we do the math and we say that this is symmetric to this, as we've done so many times, and this is 11.6, then 28 take away 11.6, and I'll just do that quickly on the calculator. 28 minus 11.6 is 16.4, but remember 16.4, there are two symmetric sides, so I divide that by 2, and I come up with 8.2 here. Since everybody's congruent, everybody's symmetric, I can figure out one side, and I know all the sides. So if we crunch numbers, okay, and I'd like to show you alternative ways down the road. I'm going to get that over here, I'm going to figure out what this isosceles triangle is. So I'll just crunch numbers this time. There are other nice ways to do it, and there's c squared. So there's a squared plus b squared equals c squared, so it's 2 times 8.2 squared equals x squared. Okay? All right? Since they're like terms, we can add them together. And when we put everything into the calculator, which I'll allow you to do, you're going to end up with 134.48, I believe it is. That's what you end up getting when you square this and multiply it by 2, following the laws of PEMDAS. And there we go. That equals x. There we are, the math that we've done so many times. Then the math turns out to be 11.596. So if we round out here, we round here to here and here to here, we end up with 11.6, off only by a tiny bit. And let's just see how much we're off by. It's worth doing these things because really this is what science is all about. And we have, this is what we'll be doing as you'll be doing in high school. 11.6 minus 11.592. Whoops, back one. Okay. And okay, we'll try one more time. I'm sorry I'm wasting time. 11.6. Oh, I see what I didn't clear everything. 11.6 minus 11.592. Should only take a second. Look what the difference is. It's 0.008. So it's 8 over 1,000. The difference, which is 2 over 250, which is a tiny percentage, okay? So they meant this to be a regular octagon. We showed using the math that we know from Pythagoras that this stuff works, and we calculated within 8/8,000th the perimeter of this. So what is the perimeter? Effectively 11.6 times 8, so there's 48, there's 2, and there's 1. So approximately 92.8. And what unit did they use on the test? We're sort of taking things to an extreme here. Centimeters, approximately. Okay? All right, so that was a little aside, as they say in math. But I want to put everything together so kids see that it all makes sense, the whole thing. So now I'm erasing the top figure, putting the numbers together here. Everything's being erased. And we're doing number 39, which will take much less time. And by the way, in number 30, excuse me, 29 we just did. In number 30, I could also calculate the surface area, but I get 2 radicals, And I don't know to what extent the class is interested in getting into complicated numbers like that. So we'll leave that aside. So you were taught that there's my picture of what's going on here, okay? And this is meant to be a pentagon birdhouse. And I'll just make the little lines here. And even though you have a copy there, you can see pretty clearly if you look at it. Let me bring it over here a little bit, okay? Where I make the lines, where you got the little birdhouse there. So it's the pentagon, as you were taught, times the length equals the volume. And you need to know that. That's just standard math that high school kids and 8th graders should know. You were taught that, okay? So I have to come up with the volume now, and I believe the volume is in cubic inches. So with the data they gave me, there's no use of Pythagoras here. This is not a slant. This is just the length. So I look at the math here, and it's the trapezoid plus the triangle, which fits snugly on the top. We use that word. And then I'm going to multiply that times 7. Are we good? Okay? So you were taught that. You would be expected to do a problem like that. It's quite reasonable to ask you to do that. So I'll figure out what the area is, the area of the pentagon times the length. And once I get the area of the pentagon, I'm sort of home free. I think you understand that. And all I have to do is multiply that times 7, and I'm done. So let's see what we come up with here. The pentagon is, there's only one that we do now. You shouldn't confuse it with surface area. It's the face times the length. The face happens to be a pentagon in this case. So the length is 8. The top is 12. The bottom is 10. And we divide that by 2. That shouldn't be foreign to you. That's the formula for a trapezoid. Plus, and they give you, there's no slant here or Pythagorean theorem. The base here is 12. It's 1/2, whatever that is, times 12. And then they're forced to give you the height here, which is 14 minus 8, which is 6. You should be able to figure that out at your age. Okay? So the height here, if I can make it so sloppy here, is 6, but they expect you to figure it out. That's a completely reasonable thing to do. We cancel here, and we get 4 times 22, and then we'll just take plus 6 times 6, and then that turns out to be 88 plus 36, and then that would be times 7. So all I have to do is put that in the calculator, and when I put that in the calculator, I come up with choice D. And you can check me. I don't think you need me to do all that stuff. And finally, we'll do 31. We're getting to the end of as much as we can do here. And 31 is a word problem. They're only asking you if you get the concepts, as I repeatedly said. It's a quite reasonable problem. It is also off of the Common Core test. Notice all 3 are Common Core problems. Okay, so they're expecting you to be able to do these things. A little dirty here, I'll fix that up in a second. And they say that you have a serving bowl that has 2 parts, a half sphere inside a cylinder. So, come on, man. It shouldn't be a mystery to you guys. And there's the half sphere, okay? And there's the cylinder. And they're asking you to keep the food out, which is the volume and the water of the cylindrical base. So they're just asking you to find the shaded area here. Okay? So you should be able to do that. Now, they're not giving you any data in this problem. They're just asking you to set it up. Well, the volume of the cylinder is that, and the half sphere is represented by that, all the rest of the answers, D is a full sphere, and you certainly don't add, and I don't know why you'd write out the cylinder as A just says, and that's all they're asking you to do, and that turns out to be choice C. Okay, so we got these 3 problems done. I spent a little bit of time on it, no big